All right, welcome again to Good Choices. As I think, as I talked about in my other videos, it's just really hard to know what to study, what to get into. I kind of kick myself for not getting into cloud and and not doing more with AI. But then today I tried to do a AI demo on YouTube, and I realized the reason I'm not in cloud and AI is because you have to give over your credit card number to do stuff like that, and then if you're not careful, you could end up charging yourself $20,000 because you messed up a parameter. So it's like that's why I'm not in that because I'm just not like I'm careful with my finances for a good reason. So anyway, that's a big reason why I'm doing the LPIC. All the training is free. You just got to pay for the tests. And I believe there are other certifications like that. We talked about the MIST certification. We talked about these Python certifications. And then these are the ones where you have to give over your credit card number and not just to actually schedule the tests, also for the training, as far as I know. All right, so let's continue on. We're at lesson one still, but we're on 102. So unfortunately, we have to get through all four of these 101, 102, 103, and 104. We are at the last section of 102, so that's good news. We're about halfway through. So yeah, making lots of progress. The topic is Linux installation and package management, and the objective is Linux as a virtual guest. Introduction. One of the great strengths of Linux is its versatility. One aspect of this versatility is the ability to use Linux as a means of hosting other operating systems or individual applications in a completely isolated and secure environment. This lesson will focus on the concepts of virtualization and container technologies, along with some technical details that should be taken into consideration when deploying a virtual environment on a cloud platform. Aha, we're learning about cloud here for free. Haha, didn't give my credit card number over yet. I will once I take the exam, but it'll only be $200 for now. Virtualization overview. Virtualization is a technology that allows for a software platform called a hypervisor to run processes that contain a fully emulated computer system. The hypervisor is responsible for managing the physical hardware's resources that can be used by individual virtual machines. These virtual machines are called guests of the hypervisor. And from my studies, I know that there are type 1 and type 2 hypervisors. Type 1 hypervisors are, they basically constitute the whole hardware of the device. Whereas and then they can't be run on top of like an operating system. They basically like are the operating system. And then type 2 hypervisors are they can be virtualized. So we're going to learn about that, refresh that, but that's my current memory of that. Type 2 hypervisors have more flexibility than type 1 hypervisors, but type 1 hypervisors have more power, I think. I don't know. Let's continue. A virtual machine has many aspects of a physical computer emulated in software, such as the system's BIOS and hard drive disk controllers. A virtual machine will often use hard disk images that are stored as individual files and will have access to the host machine's RAM and CPU through the hypervisor software, be it type 1 or type 2. The hypervisor separates the access to the host system's hardware resources among the guests, thus allowing, and guests are virtual machines created by the hypervisor, thus allowing for multiple operating systems to run on a single host system. Commonly used hypervisors for Linux include XEN, so Gen, I guess, or Xen, I'm not sure. But it's a open source Type 1 hypervisor, meaning that it does not rely on an underlying operating system to function. There we go, got that right. A hypervisor of this sort is known as a bare metal hypervisor, since the computer can boot directly into the hypervisor. Kind of got that one. Whatever I said, that's what I meant. And I was going to use the term bare metal, and I'm not sure if I did or not, but I have a good understanding of a Type 1 hypervisor. It's just sometimes when you sometimes it's hard to find the right words, which is kind of a problem. But Type 1 hypervisor does not rely on an underlying operating system, and the computer can boot directly into a Type 1 hypervisor. The next commonly used hypervisor for Linux is KVM. It's the one I'm using in my lab. The kernel virtual machine is a Linux kernel module for virtualization. KVM is a hypervisor of both Type 1 and Type 2 hypervisor. It's a hypervisor of a hypervisor. Because although it needs a generic Linux operating system to work, it is able to perform as a hypervisor perfectly well by integrating with a running Linux installation. Virtual machines deployed with KVM use the libvirt daemon and associated software utilities to be created and managed. So let's take a look at my home lab and see that running. Okay, so there should be a command, maybe top can be used. We should see a daemon running. It's the libvirt. We should see that hopefully. So I don't see libvirt. What happens if I spin up a lab? Does libvirt so we're gonna do the here, so and then we're gonna spin up these machines, and hopefully we see libvirt, because that makes sense to me. If we don't see libvirt, then that doesn't make sense to me. All right, so we don't see libvirt. We see QEU. So this is probably the same as libvirt. So let's ask the AI. We'll always have the option of doing that, so let's not take that for granted and be grateful for the advantages and power we have. So what I'm going to say is I don't see... So I am running KVM on my home lab. I am running the command top to try to see the libvirt daemon in action. I have two virtual machines running via GNS3. But in the top command, I do not see libvirt. Why? Okay, so top command is process filtering. Okay. Oh, so sometimes it doesn't show like background processes. Okay. So you know what? Let's do that. Let's try. So we can do PS instead to look at all processes. Another thing we can do is try to just use sudo on the top. So libvirt. I don't see libvirt. I don't even see the QMOs anymore. Oh, there they are. Okay. Also, there's a better command called htop. It's like way better. So here we see some demons. Unfortunately, we only I don't understand why the demons are named this way, but this is what I would be expecting to see libvirt. And we do. Okay, we got libvirt. Yay! So here's the libvirt demon. Looks like we've only got one instance of that. It's interesting that the other demons are like the usernames. I wasn't expecting that. Here's the good old-fashioned system D. We know exactly why we have that running as a daemon, because it's our service manager. But other than that, we've just got oh, you know what? It says user for some reason. Okay, I see. So this is not a header. This is a the user is the daemon, and then here there are different users. So that's kind of interesting that when a daemon is created, it appears to be created as a user in some context. So this like libvirt daemon is listed as a user. That's fascinating to me. Okay, so then the next command is ps. This looks at all the this looks like the processes running on the system, but we're gonna need to see all of them, so we can do ps all. And now okay, well that's interesting. Where is the now it said oh, ps aux. I don't see aux listed in the ps help. I mean, there's a what about ps help? Oh, the okay, I get it. These are options for so when we do ps-help, it tells us the options, and then we can get help on more things. So aux should be in here now that we're getting all the help that's available, which is not as much as we need. We need more help than that, but keep on going. Okay, AUX. Do not see AUX. I definitely want to do that -F. Oh. Why can't I do the... Oh, it's not a dash. Oh, there we go. Oh, okay. Yeah, this is good. This is good. So you can do forest, and then I don't know how we can know to do the, but like we can see this. We can see like how the processes were spawned. So like here's the libvirt. Oops, and I dropped my mouse. Let me get that. Yeah, libvirt plus. Looks like there's a process spawn due to that. Let's do a pipe grep on that. Just the one. Okay, but anyway, we see libvirt. That was the goal. I unfortunately do not see aux. Oh, here we go. Oh, okay. Well, where's it feels like aux is like esoteric knowledge. Oh, here we go. Here we go. So here's how you see to see every process. on the system. Okay, so we don't have to do that aux, which is good because it's not in the help. But we can do -E, and now we see every process on the system. So pipe grep libvirt. Don't see anything there. Let's go back to the manual page. Man is kind of esoteric knowledge as well, or sorry, like idiomatic knowledge or like whatever. It appears like aux is idiomatic knowledge as well. I don't see anything in any of the help resources that tell you to use aux. Yeah, it's there's nothing that tells you like what aux means. So it's like idiomatic knowledge. You have to know about aux in advance in order to use it. You can't just be on the CLI and look at it in the manual, it looks like. All right, so that's KVM. That's the one I'm looking at. So we took a look at that. VirtualBox is another one I've used extensively, but I've decided to go with KVM. So VirtualBox is a popular desktop application that makes it easy to create and manage virtual machines. Oracle VM VirtualBox is cross-platform and will work on Linux, Mac OS, and Microsoft Windows. Since VirtualBox requires an underlying operating system to run, it is a Type 2 hypervisor. I got to change my posture here. All right, there we go. Posture is absolutely essential. If you ever feel like you're having a pain, your back is going out, the first thing you need to do is change your posture, because it'll just get worse and worse and worse unless you do that. All right, yep, perfect posture. Some hypervisors allow for dynamic reallocation of a virtual machine. The process of moving a virtual machine from one hypervisor installation to another is called migration, and the techniques involved differ between hypervisor implementations. Some migrations can only be performed when the guest operating system has been completely shut down, and others, missing an S here, can be performed while the guest is running, called a live migration. Such techniques can be of aid during maintenance windows for hypervisors, or for system resiliency when a hypervisor becomes non-functional and the guest can be moved to a hypervisor that is working. All right, so next section, types of virtual machines. There are three main types of virtual machines. And virtual machines are not hypervisors. In the context of a hypervisor, a virtual machine would be referred to as a guest. So there are three types of virtual machines, also known as guests from the context of a hypervisor. The fully virtualized guest, and you can see we're using that term here. The para-virtualized guest and the hybrid guest. So they could be called a fully virtualized virtual machine, para-virtualized virtual machine, or a hybrid virtual machine, but we're using the term guest here. So fully virtualized guest. All instructions that a guest operating system is expected to execute must be able to run within a fully virtualized operating system installation. The reason for this is that no additional hardware drivers are installed within the guest to translate the instructions to either simulated or real hardware. A fully virtualized guest is one where the guest or hardware VM is unaware that it is a running virtual machine instance. In order for this type of virtualization to take place on x86 based hardware and the Intel VTX or AMD V CPU. Okay, so in order for this type of virtualization to take place on x86 based hardware, the Intel VT-X or AMD-V CPU extensions must be enabled on the system that has the hypervisor installed. This can be done from a BIOS or UEFI firmware configuration menu. So this is a big one. Um, you'll be trying to set up VirtualBox or something and it won't work. It's because you need to configure your BIOS to allow for this kind of virtualization. The next kind of virtualization is para-virtualized. A para-virtualized guest, or PVM, is one where the guest operating system is aware that it is running that it is a running virtual machine instance. So the guest operating system would be the operating system of the virtual machine. In the case of a para-virtualized guest, it is aware that it is running that it is a virtual machine. Okay, and that's different from a fully virtualized guest because a fully virtualized guest is unaware that it is a virtual machine. It just believes it's a regular physical machine. These types of guests will make use of a modified kernel and special drivers known as guest drivers that will help the guest operating system utilize software and hardware resources of the hypervisor. The performance of a para-virtualized guest is often better than that of a fully virtualized guest due to the advantage that these software drivers provide. So the third kind of guest is a hybrid guest. Para-virtualization and full virtualization can be combined to allow unmodified operating systems to receive near-native I/O performance by using para-virtualized drivers on fully virtualized operating systems. The para-virtualized drivers contain storage and network device drivers with enhanced disk and network I/O performance. Virtualization platforms often provide packaged guest drivers for virtualized operating systems. The KVM utilizes drivers from the Vertilo project, whereas Oracle VM VirtualBox uses guest extensions available from a downloadable ISO CD-ROM image file. Alright, so next section, example libvirt virtual machine. We will look at an example virtual machine that is managed by libvirt and uses the KVM hypervisor. A virtual machine often consists of a group of files, primarily an XML file that defines the virtual machine, such as its hardware configuration, network connectivity, display capabilities, and more, and an associated hard disk image file that contains the installation of the operating system and its software. First, let us start to examine an example XML configuration file for a virtual machine and its network environment. So here it is, the QEMU virtual file. Let's see if it exists on my home lab. And it does. We don't have this Red Hat Linux file, but I mean, it's not Red Hat Linux. I'm curious to see if it's on the CentOS, because CentOS is Red Hat Linux. Nope. It doesn't have the ability to run virtual machines, as far as I know. KVM I don't think KVM is set up on that, and it's a virtual machine itself, so might be some issues there. Let's take a look at this. SUSE Linux box. Okay, it's not really loading up here. Oh, now it's loading. There we go. Oh, and I don't have a shared clipboard, unfortunately. Okay, so there it is. ls/etc/etsy/libvirt/kimu. Nope, nothing on there as well, which makes sense. KVM probably isn't set up on those boxes, and they're virtual machines, so it might not even be possible to set up KVM on them anyways. So next section, or next part is the note. The kimu portion of the directory path refers to the underlying software that KVM-based virtual machines rely on. The kimu project provides software for the hypervisor to emulate hardware devices that the virtual machine will use, such as disk controllers, access to the host CPU, network card emulation, and more. Note that there is a directory named networks. Yep, saw that in my home lab. This directory contains definition files, also using XML, that create network configurations that the virtual machines can use. This hypervisor is only using one network, and so there is only one definition file that contains a configuration for a virtual network segment that these systems will utilize. So let's take a look at my home lab. Okay, that's what we saw before. So we should have a default, or that's not what we saw before. So this is auto start and default.xml. Yep, got those both. So let's take a look at the default.xml file. Looks like we need a escalation of privileges. Okay, so we escalated the privileges. We've got an auto-generated file here. We should not make changes to this file. Instead, we should use virsh, edit default. Probably shouldn't edit the default either. But here we go. This looks like XML to me. We've got our opening and closing tags for each of the things here. So, yep, looks pretty straightforward. This definition includes a Class C private network and an emulated hardware device to act as a router for this network. There is also a range of IP addresses for the hypervisor to use with a DHCP server implementation that can be assigned to the virtual machines that use this network. This network configuration also utilizes network address translation, NAT, to forward packets to other networks, such as the hypervisor's LAN. So here we go. We're back. Yeah, this is this is network engineering. This is networking. It's just doing it on a different kind of machine, a Linux machine. So that stuff never goes away. It's always important. It's always present. So getting the CCNA, and stuff like that makes sense. For me, it's just, this kind of confirms, what use is a CCIE in this case. What I want is universally applicable, transferable, high value skills that I can use in numerous situations. So just basic CCNA skills where what DHCP is, what an IP address is, a MAC address. That's what matters. EVPNs, particularly EVPNs, like path discovery with LDP and RSVP for MPLS, and MPLS tear messages, the very the intricate, painful details of BGP links, or what, I don't even know what it's called. The information contained within BGP update messages. This is bothering me. So it's like BGP messages. Yeah, like the types and states of BGP communication messages that open the keep alive the update, and the next hop reachability information is what I'm thinking. NLRI. Yeah, that's what I'm thinking. Network layer reachability information, NLRI. Um, you know, okay, great. I didn't even know that, and I had to look it up. I didn't even know it. And it's like, yeah, like NLRI is like a part of the update messages, and it's NLRI, network layer reachability information. That's like the um, where is it? It's right here. Path attributes are part of the. Actually, so this is an update message format. It contains the NLRI, the path attributes, and the withdrawn routes. Um, Probably also this looks like a different kind of because I'm pretty sure it's not just the withdrawn. I'm pretty sure it does the same thing if it wants to add routes. But the NLRI, network layer reachability information, is exchanged between BGP routers using update messages, and NLRI is composed of a length and a prefix. The length is a network mask. The prefix is the network address for that subnet. It's unique to version 4. It allows to carry supernetting information as well as perform aggregation. So I was wrong about that. NLRI is not the same thing as path attributes. It's a part of the message that includes path attributes, the update message, but it is not itself another word for a path attribute. So like, okay, great, wonderful, great. That's great. MAC addresses, IP addresses, DHCP, NAT, basic CCNA stuff. That's what's universally applicable and useful across all fields, not the intricacies of what NLRI is and like how it's different from path information. It's like, just plug in the damn numbers in the configuration, and like that's not, I don't know. Well, whatever. Okay, and I probably sound pretty stupid right now because that stuff probably is pretty damn important. And if I had not failed my JNCIESP and my Encore, I would probably have different opinions than I do now. Okay, so here we go. We went through that. So next section, this definition includes a Class C. Oh yeah, we read this already. This is basic CCNA networking, which we see popping up like Where's Waldo in this. Now we turn our attention to a Red Hat Enterprise Linux 8 virtual machine definition file. Sections of special notes are in bold. So we got the domain type is special node, KPM, the name is a special note, the memory unit. Looks like quite a bit of memory. I guess only 4 gigs. That's not that much. vCPU placement static. 2 is a special thing to note. All of these things are special to note. As is this, the MAC address information, the input information. Okay. This file defines a number of hardware settings that are used by this guest, such as the amount of RAM that it will have assigned to it, the number of CPU cores from the hypervisor that the guest will have access to, the hard disk image file that is associated with this guest under the disk stanza, its display capabilities via the spice control. Ooh, spicy. Hope it's not too hot. And the guest's access to USB devices, as well as emulated keyboard and mice input. All right, example virtual disk storage. This virtual machine's hard disk image resides at /var/lib/libvirt/images. So let's see if we've got some images on my machine. ls. Oops. Nope, none of them. Okay, here is the disk image on the hypervisor. There we go. And this -H means human readable form. So we see the gigabytes there listed in a more human readable form. -L, we all know, that shows the permissions, file permissions, file directory permissions. This is a file because it doesn't have the D here. And then the user that owns the file, and then the group that that user belongs in, and then of course the date, and then the absolute path to the file. We know that because of the /. The current size of this disk image consumes only 5.5 gigabytes, not bits, bytes, of space on the hypervisor. However, the operating system within this guest uses a 2.3 gigabyte sized disk, as evidenced by the output of the following command from within the running virtual machine. Then that's a really important distinction to make. How is it that this file is only 5.5 gigabytes if it is true that the file is to build a virtual machine that is 23.3 gigabytes? Well, the answer is this is due to the type of disk provisioning used for this guest. There are multiple types of disk images that a virtual machine can use, but the two primary types are cow and raw. So the cow stands for copy on write, also referred to as thin provisioning or sparse images, and it is a method where a disk file is created with a predefined upper size limit. The disk image size only increases as new data is written to the disk. Just like the previous example, the guest operating system sees the predefined disk limit of 23.3 gigabytes, but has only written 5.5 gigabytes of data to the disk file. The disk image format is used for the example. The disk image format used for the example virtual machine is QCOW2, which is QEMU cow copy on write file format. So this is thin provisioning or sparse images. It's a message where a disk file is created with a predefined upper size limit, and then the reason it's 5.5, even though the machine is 23.3, is because that 23.3, all that is a max. It's the biggest that the machine can ever be. When you first install it, the machine is only 5.5, but as you add files to it, as you grow it, it's going to be up to 10, 15. But once it gets up to that 23.3, then the predefined disk limit has been hit, and you will not be able to write anymore to that virtual machine. It will run out of disk space. So this is a method called a copy on write, which is also known as thin provisioning or sparse images, and it allows you to have a virtual machine on your system that does not take up as much space as the virtual machine is. You don't always have space set aside for the virtual machine. You're just using as much space as is necessary to have on the virtual machine, and then you have to set a limit for the maximum size of the virtual machine. And that's different from raw. A raw or full disk type is a file that has all of its space pre-allocated. For example, a 10 gigabyte raw disk image file consumes 10 gigabytes of actual disk space on the hypervisor. There is a performance benefit to this style of disk as all of the needed disk space already exists, so the underlying hypervisor can just write data to the disk without the performance hit of monitoring the disk image to ensure that it has not yet reached its limit and extending the size of the file as new data is written to it. And the other thing to be aware of, I worked as my internship for school was at a data recovery company. Actually, I can say the name of the company. Free advertising for them because of like my millions of people that are watching right now. So, Gilware Data Recovery, I worked there as an intern, and one of the things I learned is that these sorts of distinctions really matter if your drive fails and you need to use a data recovery service, because it can make it more or less likely that your files are recovered. So, I don't remember if this was mentioned specifically. I remember one. I don't know if they'll mention it later, but there's a way of storing files where the files will be fractured out through the disk versus where they'll be all in one solid chunk. And I think it's this. I think this is what it is. I'm not 100% sure, but we do see for thin provisioning, it's going to be written to the disk as new data is there. So that might be out of order because let's say you're doing something on your machine, real machine, not your virtual machine, and it writes it to so the first, second, and third writes to the disk are by your virtual machine. You shut that virtual machine down, use your regular machine. Now the fourth, fifth, and sixth are by your regular machine. You start the virtual machine back up. Now the seventh, eighth, and ninth are by the virtual machine. So like when you're trying to recover the data for the virtual machine, that's going to be a nightmare because you have to identify for each write on the disk. Does that belong to the virtual machine or does that belong to the regular machine? But if you're using something like RAW, all you have to identify is the disk space of the virtual machine. And then you know that all of the files within that space belong to the virtual machine. You don't need to piece things back together that have been fractured. So that's just one of the many things you need to consider when it comes to data recovery, which is, I think, a very necessary evil in a lot of cases. Hopefully you'll have your backups and it won't be an issue, but yeah, it happens, and I believe, from what I remember, you can get some advantages by using RAW. Not only is there performance benefits that the disk space is there, ready to go, and it does not have to be searched for and allocated. When you recover your data from your drive, if it fails, it will all be in a predefined space that is easy to look through. All right, so the next section. There are other virtualization management platforms such as Red Hat Enterprise Virtualization and OVIRT that can make use of physical disks to act as backing storage locations for a virtual machine's operating system. These systems can utilize Storage Area Network (SAN) or Network Attached Storage (NAS) devices to write their data to, and the hypervisor keeps track of what storage locations belong to which virtual machines. These storage systems can use technologies such as logical volume management (LVM) to grow or shrink the size of a virtual machine's storage disk as needed, and aid in the creation of management storage snapshots. So besides just a copy and write and full disk or RAW, there are other virtual management platforms, and you can use Storage Area Network or Network Attached Storage to write there. So you don't have to write it on the disk that exists on the same device that your hypervisor is installed on. Instead, the guest, the virtual machine created by the hypervisor, can have its disk exist in a storage area network, so some other storage device on your network besides the device that the hypervisor exists on, or network attached storage devices in another building, a whole different network, like WAN across WAN, I think is what that probably means. Okay, so the hypervisor keeps track of what storage locations belong to which virtual machines. These storage systems can use technologies such as logical volume management to grow or shrink the size of the virtual machines. So here, if you're doing data backup and data recovery, this is going to be an absolute nightmare because your data doesn't even exist in the same room. It's over on the network. So that's one thing to consider. This is probably a solution that is important to know about and to consider. But there's a lot of things to consider, and I think one thing that's not considered, probably to the level it needs to be, is what happens when everything fails and you need to do data recovery. I think that's relevant to these sorts of decisions. All right, next section, working with virtual machine templates. Since virtual machines are typically just files running on a hypervisor, it is easy to create templates that can be customized for particular deployment scenarios. Often a virtual machine will have a basic operating system installation and some pre-configured authentication configuration settings set up to ease future system launches. This cuts down on the amount of time it takes to build a new system by reducing the amount of work that is often repeated, such as base package installation and local settings. This virtual machine template could then later get copied to a new guest system. In this case, the new guest would get renamed, a new MAC address generated for its network interface, and other modifications can be made depending on its intended use. All right, so next section, the D-bus machine ID. Still got quite a bit to go here. We're at the 47-minute mark. I would like to let's try to get to this cloud section, which is great, by the way. Oh my god, we're learning about cloud and we're doing it for free. Like, oh my god, this is so amazing. Thank you, LPIC, for being beautiful. Okay, so yeah, we're gonna learn about the D-bus machine ID, and then we're gonna take a break and split this into two parts. Part one will be all about hypervisors and virtual machines, and then part two will be all about cloud, all about hypervisors and virtual machines, but as is relevant to the cloud. Okay, so next section is the D-bus machine ID. Many Linux installations will utilize a machine identification number generated at install time called the D-bus machine ID. However, if a virtual machine is cloned to be used as a template for other virtual machine installations, a new D-bus machine ID would need to be created to ensure that system resources from the hypervisor get directed to the appropriate guest system. The following command can be used to validate that a D-bus machine ID exists for the running system. Alright, so let's see if this exists on my home lab. It does not. If no error messages are displayed, oh, okay. Then it does. So a machine ID does exist on my system. Then an ID exists for the system. So we'll probably get an error message for this other one here that I can copy paste into. So nope, no error message on there either. That's interesting. Okay, so to view the current dbus machine ID, run the following. There we go. Boom. We got an ID. It's a big deal. Oh, we got an ID on the CentOS box as well. The string of tests that is displayed is the current ID number. No two Linux systems running on a hypervisor should have the same dbus machine ID. The dbus machine ID is located at /var/lib/dbus/machine-id and is symbolically linked to the /etc/machine-id. Okay, that's interesting. I wonder if my if I go to Bash. Now this is Wassel. This is Windows subsystem for Linux. So it's a virtual machine, right? It is, yeah. So it has its own virtual machine ID. I think if we were just straight running, oh, but that's what's kind of interesting because my home lab is not a virtual machine. It's just an operating system on a bare metal on the actual device. It's not virtualized, but it has an ID. Interesting. Oh, you know what? This is a dbus machine ID. So many Linux installations will utilize a machine identification number generated at install time. So it's kind of like your PC name in Windows. Um, so if a virtual machine is cloned to be used as a template for other virtual machines, a new dbus machine ID. The dbus machines all have to be unique from one another. So if you're cloning a virtual machine, you have to change the dbus machine ID. I think is the main point of this section of the reading. Yeah. And this is basically just like your system name for your PC. Um, every Linux system, whether it's virtualized or not, will have a ID like this. If it doesn't have an ID, uh, maybe it's because you created a virtual machine and erased that ID in the virtual machine configuration files. But you need that ID. To ensure that system resources from the hypervisor get directed to the appropriate guest system. If it's a virtual machine, if it's not a virtual machine, you probably still need it to identify the system. But there are some distributions that do not utilize a machine identification number generated at install time. Or if they do, it's not called the dbus machine ID. It's some other system of doing that. All right, moving on. The string of text that is displayed is the current ID number. No two Linux systems running on a hypervisor should have the same dbus machine ID. The dbus machine ID is located at /var/lib/dbus/machine-id and is symbolically linked to /etc/machine-id. Changing this ID number on a running system is discouraged as system instability and crashes are likely to occur. If two virtual machines do have the same dbus machine ID, follow the procedure below to generate a new one. So we can do this on my virtual machine here because I can just blow that away. Can't do it on my home lab. That would be terrible. In the event that /var/lib/dbus/machine-id is not a symbolic link back to /etc/machine-id, then /var/lib/dbus/machine-id will need to be removed. All right, so let's try this on my virtualized CentOS machine because it doesn't really matter if that gets blown away. So, yep, I removed it. So if we do the ensure command, now we should see the error message. And we do. Wait, what? Oh, you know what? That just created a new one. That's weird. Okay. It didn't say that it did that. That's interesting. All right. Well, anyways, let's try it again with the git, because we should have a. What the heck? That makes no sense. Well, I mean, we got one. Is it the same? No, we made a new one. When we did this remove, and then we did the ensure, we made a new one. So let's do it again. Alright, let's see what we got here. Oh, now we don't have a new one. That makes no sense. Okay, well, I'm confused, but I don't think it's that confusing. It's just a machine ID. That doesn't have to be confusing. Where it gets confusing is if you clone a virtual machine, then the machine ID might be identical to another machine, which would cause problems. The system resources from the hypervisor might have issues being received in the proper way, and system instability and crashes are likely to occur. And that's the case as well. If you change it, just stop. Just stop. Everyone stop. Put down the key. Unplug the keyboard for a bit. Read this section, and then forget what you read, because it's not relevant. If you don't have one of these, your system is hosed. Although it is relevant to cloning virtual machines, to virtual machine administration. So don't forget what you read. Remember what you read, and get that cert. Get that cert. All right. So the next section is deploying virtual machines to the cloud. Ooh, the cloud is like the biggest buzzword in technology right now. Like, hey, let's get our heads in the clouds. Take our heads out of the clouds right now, and stop this here, and then we'll come down and devote an entire video to the cloud, with gold, silver platters, and I'll wear a tuxedo, and we'll give this the reverence that it is due. I'll take my laptop to church, and we'll learn about this sacred concept that is so highly valued in the field this day. All right, so that's it. Thanks for watching. When we come back, we'll be learning about the cloud.